जय सीताराम जय सीताराम जय सीताराम जय बजरंग बली जय हनुमान जी जय हनुमान जी जय हनुमान जी. Welcome back to my lecture series, computer lecture series, that is learning computer with seeing the natural sights of Indian village. And in this lecture I would like to talk about the assembler. And so let's talk about the assembler and what is assembler. So assembler, a computer can directly execute only machine language programs which use numbers for representing instruction and storage locations. Here we must convert, translate an assembly language program into its equivalent machine language program before executing it on the computer. A translator program called assembler does this translation. Assembler Assembler is the system software supplied by computer manufacturers. It translates an assembly language program into its equivalent machine language program. It is so called because in addition to translating, it also assembles the machine language program in main memory of the computer and makes it ready for execution. The input to the assembler is an assembly language program, often referred to as source program, and its output is the equivalent machine language program, often referred to as object program. Since the assembler translates each assembly language instruction into an equivalent machine language instruction, there is one-to-one correspondence between the assembly language instruction of a source program and the machine language instruction of its equivalent object program. Note that during the process of translation of a source program into its equivalent object program by the assembler, the source program is not under execution. The assembler only converts it into a form that the computer can execute. Notice that in the case of an assembler language program, the computer has to run the assembler program first to translate the original assembly language program, that is called source program, into its equivalent machine language program, which is a object program, and then execute the object program to get the result. This means that the computer has to spend more time in getting the desired results from an assembly language program as compared to a machine language program. However, assembly language programming saves so much time and effort of a programmer that the extra time and effort spent by computer is worth it. This conversion time is one time and very small in case of stored program computers. Once the system obtains the object code, it can execute it as many times as required. For example, assembly language program inputted into assembler, then outputted into machine language program. And assembly language program, that is source program, one-to-one correspondence with object program. For example, can we best illustrate assembly language programming and translation of an assembly language program into its equivalent machine language program. Let us assume that a computer uses the mnemonics for the operation codes mentioned against each. For simplicity, we have considered here only 5 operation codes, 3 operation codes for writing our example program. Like this, there can be more than 100 operation codes available in this instruction set of a computer. For example, the instruction add and location code 14 and the add to the content of a register. Instruction sub 15 subtract from content of a register. sta 30 store a register. Now let us write a simple assembly language program for adding two numbers and storing the result. To get an idea of how the assembler converts this program into an equivalent machine language program, let us follow its instruction one by one. Notice that the first 5 instructions of the program are pseudo instructions for telling the assembler what to do, and they are not part of the main program to add the two numbers. Let's see a simple assembly language program for adding two numbers and storing the result. So the first line cap start space cap program at cap at 0000. Next line cap start cap data at cap at 1000. Next line cap set cap aside cap and cap address cap for cap frst. Next line cap set cap aside cap and cap address cap for cap scnd. Next line cap set cap aside cap and cap address cap for cap ansr. This first code this first 5 instruction of the program are pseudo instruction for the telling the assembler what to do. Now next instruction C cap cla frst cap add scnd cap sta ansr, and next last is hlt, that is halt. The first instruction of the assembly language program tells the assembler that the instruction for the main program to add two numbers should start at memory location 0000. Based on this directive, the assembler loads the first instruction of the main program, which happens to be clear frst in this example at memory location 000. It loads each subsequent instruction in the following memory location, that is add, scanned, add scnd at location 001, sta ansr at location 0002, and hlt at location 003. The second instruction of the assembly language program tells the assembler that the data of the program should start at memory location 1000. The next 3 instructions tells the assembler to set aside addresses for data items frst, scnd, and ansr. Based on these 4 directives, the assembler sets up a mapping table somewhere in the computer memory that looks somewhat like as here, that is symbolic name in the first column and the second column memory location. The first frst memory location 100, SCND memory location 101 and ANSR memory location 1001. That is, the assembler picks up the first free address in the data area of the program, which is location 100, and calls it FRST, cap FRST. It picks up the next free address in the data area, which is location 1001, and calls it cap SCND. Finally, it picks up the next free addresses in the data area, which is location 1002, and calls it cap ANSR. The next instruction of the assembly language program is CLA FRST, which the assembler translates into 10100 by translating cap CLA into 10 and FRS2 into 100. So with this, the assembler do this works. Now let's see the advantage of assembly language over machine language. Assembly language have following advantage over machine language. First, easier to understand and use. Due to the use of mnemonics instead of numeric opcodes and symbolic names for data location instead of numeric addresses, assembly language programs are much easier to understand and use than machine language program. The second point, easier to locate and correct errors. Due to the use of mnemonic opcodes and symbolic names for data location, and also because programmers need not keep track of a storage location of the data and instruction, few errors are made while writing program in assembly language, and those that are made are easier to find and correct. Additionally, assemblers detect and indicate errors automatically for use of an invalid mnemonic opcode or an undefined name. For example, let us assume that an assembly language program instruction read cap add cap area, and we forget to define cap area in the program. The assembler will look through its table, and not finding cap area in it will indicate the error. The next point, easier to modify. Since they are easier to understand, it is easier to locate, correct and modify instruction of an assembly language program than a machine language program. Moreover, insertion or removal of certain instruction in a program does not require change in address part of the instruction following that part of the program. This is required in the case of a machine language. Next point is no worry about address. No worry about address. An important advantage of assembly language is that programmers need not keep track of storage locations of data and instructions while writing an assembly language program. For example, let us assume that we have written a long machine language program involving many instructions and several references to itself within the program, such as looping, branching, and so on. At the very end, we discover suddenly that we have left out an instruction in the middle. If we insert that instruction, we will have to go through the entire program to check and modify if necessary. This is not possible easily with machine language program. An example can best illustrate suddenly that the program uses another program which also start at location. An example can be illustrated this feature. Let us assume that an uh, assembly language program start at address 100 and we find suddenly that this program uses another program which also start at location 1000. Obviously we will have to rewrite one of the two programs to move it to some other location. In machine language this can be a complicated job. However, in the case of assembly language we merely have to change the pseudo instruction suitably for assembling the program for one of the two programs. For example, we change the following pseudo instruction for one of the program: cap start cap program cap at 100, cap start cap data cap at 2000 to the following pseudo instruction: cap start cap program at 3000, cap start cap data at cap 400, and run the assembly language program once again through the assembler. The equivalent machine language program will this time start at memory location 3000 instead of 1000, and there will be no conflict with the other program. In other words, we can move assembly language program easily from one section of memory to another. The next point is efficiency of a machine language. An assembly language program also enjoys the efficiency of its corresponding machine language program because there is one-to-one correspondence between the instruction of assembly language program and its corresponding machine language program. In other words, an assembly language program will be just as long as the resulting machine language program. Hence, leaving out the translation time required by assembler, the actual execution time for an assembly language program and its equivalent machine language program written independently would be the same. Now, limitation of assembly language program. Limitation of assembly language program. With the use of assembly language, we cannot solve the following limitation of machine language. First, machine dependent. Since the assembler translates each instruction of an assembly language program into exactly one machine language instruction, assembly language programs are machine dependent. That is, assembly language differ from computer to computer, and we can execute an assembly language program only on the computer in whose assembly language is the program's code. Hence, a decision to change to another computer will require learning a new language and conversion of all existing program into assembly language of new computers. Second, knowledge of hardware required. Since assembly languages are machine dependent, an assembly language program must have a good knowledge of the characteristics and logical structure of his or her computer to write good assembly language program. Third, machine level coding. In case of assembly language, we still have to write instruction at machine code level. That is, one assembly language instruction corresponds to one machine language instruction. Programs rarely write programs of any significant size in assembly language today. they where assembly language code they write assembly language code only when a program's execution efficiency is very important. Assembly language programming helps in producing compact, fast and efficient code because it gives the program more total control of the computer's central processing unit, memory and register. Hence we use assembly language programming mainly to fine tune important parts of program written in higher level language. High level language programs that are candidate for this type of fine tuning are those whose execution consumes a substantial part of the total computing resources and hence offer real play of for an improvement in execution time. In such circumstances, a clever programmer can rewrite some small but critical section of high language program in assembly language to improve its overall performance significantly. Now assembly language with macro instructions. Assembly language with micro instructions. In general, assembly languages are termed one for one in nature, that is, each assembly language instruction results in one machine language instruction. However, quite often a program uses certain set of machine language or assembly language instruction repeatedly. For example, suppose we need three instructions, one after the other, to print a value on a computer. Also suppose that a program uses these three instructions repeatedly, always in order. Instead of forcing a programmer to write the set of three instructions every time she wants to print a value, we might as well design the assembler, that is program, to substitute these three instructions for a single instruction. For instance, every time a programmer uses the print instruction in a program, the assembler would translate it into three machine language instructions instead of one, hence supplying the complete set of instructions required for printing. Any instruction such as print, which an assembler translates into several machine language instructions, is called macro instruction. There might be many such micro instructions permitted by an assembler. Hence, to speed up coding process, researchers developed assemblers which could produce multiple machine language instructions for each macro instruction of an assembly language program. The use of micro instruction adds more work to a computer because the translation process becomes more than just changing each word into a number. The assembler must be able to supply the missing instruction as well, but it means a tremendous saving of work for a programmer. The programmer is relieved of the task of writing an instruction for every machine operation performed. Hence, the use of micro instruction reduces the length of program, cut down on errors and simplifies programming. The micro instruction capability was developed very early in the evolution of computer language. In fact, it is this concept of multiple machine instruction from one macro instruction around which today's machine independent high level language are designed. Now let's talk about high level language. Due to limitation in machine and assembly language, we use high level language. We often refer to machine and assembly language as low level programming language and high level programming language. Over this limitation of low level programming language, they have following features. First, they are machine independent, that is high level programming language are machine independent, that is we can easily port and execute a program written in a high level language on any computer having translator software for the high level language. Second point, they do not require programmers to know anything about the internal structure of computer which will execute their high level language programs. In fact, since high level languages are machine independent, a programmer writing a program in high level language may not even know which computer will execute the program. This allows programmers to concentrate on the logic of the program rather than be concerned with the details of the internal structure of the computer. The third point, they not the third point, they do not deal with machine level coding, rather they deal with high level coding, enabling the programmers to write instructions using English words and familiar mathematical symbols and expression. Each statement of a high level language is normally a macro instruction that is translated into several machine language instructions. This is one to many translation and not one to one as in the case of assembly language. For example, let us consider the same problem of adding two numbers FRST and SCND and storing the sum in cap ANSR. We saw that three low level, that is machine or assembly level instructions are required to perform this job. However, if we use a high level language, say for instance, to instruct the computer to do this job, only one instruction need to be written. Answer equals to FRST plus cap answer equals to cap FRST plus cap SCND. This instruction is obviously very easy to understand and write because it resembles the familiar algebraic notation for adding two numbers like A equals to B plus C. Advent of high level language has enabled even non-expert users to use computers to solve problems. This has allowed many users without any background in computer science and engineering to become computer programmers. This in turn has resulted in the creation of a large number of computer applications in diverse areas, leading to the use of computers today in every occupation. Compiler. Now the next topic is our compiler, and this will be discussed in the next lecture. And from this I end this lecture. Jai Shri Ram, Jai Sitaram, Jai Hanumanji, Jai Bajrangwali, Om Namah Shivaya, Om Namah Shivaya, Om Namah Shivaya, Jai Bajrangwali.